Hello everyone, this is Sangeetha, Assistant Professor, ECE Department, SNS College of Engineering, Coimbatore. So in the last video we discussed about the image compression techniques or run-length coding, wavelet coding and transform coding. So in this video we are going to discuss about arithmetic coding. Let us see the basic of arithmetic coding. So unlike the variable and codes described previously, arithmetic coding generates non-block codes. So in arithmetic coding, which can be traced to the work of allies, to one-to-one corresponding between source symbols and code words does not exist. So instead, an entire sequence of source symbols, that is message, is assigned a single arithmetic code word. So that a code word itself defines an interval of real numbers between 0 and 1. So as the number of symbols in the message increases, the interval used to represent it becomes smaller and the number of information units, that is bits required to represent the interval, becomes larger. So each symbol of the message reduces the size of the interval in accordance with its probability of occurrence. Because the technique does not require, as does Huffman's approach, that each source symbol translate into an integral number of code symbols. So let us move on to the example. So in this example we have taken India, that is so in India first we have to assign the probabilities to each symbols. So first we have to calculate the frequency of each letter in the message India and assign probabilities based on their occurrence. So the I presents 2 times, the frequency of I is 2, that is 2 by 5, the total number of letters, that is 2 by 4, 2 by 5 is 0.4, and for n the frequency of occurrence is 1 and the probability is 0.2, 1 by 5 0.2, and for D it is 0.2 and A it is 0.2. So the second step is determine cumulative probability. So the so for symbol I the probability is 0.4 and the cumulative range is 0 to 0.4, and for n it is the probability is 0.2 and the cumulative range is 0.4 and 0.6, and for D it is 0.2 and the cumulative range is 0.6 to 0.8, and for A the probability of A is 0.2 and the cumulative range is 0.8 to 0.1. So the third step is we start with the initial interval 0 to 1 and update it as we encode each character of I and DIA. That is, for encode I, the cumulative range is the cumulative range for I is 0.0 to 0.4, that is new interval is 0 to 0.4, and for encode n the cumulative range is 0.4 to 0.6. So to update the interval, so it is calculated as, that is new low level interval, and for new high level interval we have to calculate. For new low level it is calculated by using the formula, that is lower level plus difference between the lower and upper levels and into the probability of occurrence. For n it is 0 plus 0.4 minus 0.0 into 0.4, that is the new lower level is 0.16, and for higher level it is calculated by the same by using the same formula, that is 0.0 plus the difference between the lower and upper levels are 0.4 into the probability of occurrence of n, does 0.6, that is 0.24. The same procedure is followed for D also. So for D the cumulative ranges 0.6 to 0.8 and we have to update the interval. So the new low range is 0.208 and new high range is 0.24, and for I it is the cumulative range is 0.0 to 0.4. To update the interval, the new low level is 0.208 and the new high level is 0.2144, and for A the cumulative range is 0.8 to 1.0. So to update the interval, the new low level is 0.213 and for new high level is 0.2144. So the final coding, the final encoded value, the final encoded value can be any number within the final interval 0.21312, 0.2144. For example, a valid encoding for India would be 0.2135. So for decoding process, to decode the number 0.2135, it starts at the interval 0, 1, and the 2135, the final value, falls in the range for 0.0 to 0.04. So the restrict the interval 0 to 0.4, the number 0.2135 within this range corresponds to the next symbol n. So the process is continued by refining the interval for each subsequent symbol until the original message India is recovered. So the arithmetic coding compresses the word India into a compact numeric value in the range 0.21312 to 0.2144. So this efficient coding method allows for higher compression rates compared to fixed length or even some variable length codes, by taking into account the probability of each symbol. So this is the method for identifying the compression ratio. So hope this video will help you to understand the arithmetic coding. Thank you.